So here is a reaction where the oxidation, or a substance is oxidized and another substance is reduced. And when we balance this, we can't always balance just using the number of atoms, because in an oxidation reduction reaction, the number of electrons being transferred has to remain constant. So if one loses 2 electrons, something has to gain 2 electrons, and if something gains 10 electrons, something has to lose 10 electrons, and so on. The formatting of this is not quite correct because of how my two machines work with each other. Oh wait, that's not solid. Oh yeah, it is. And so this is what it should look like. These are aqueous. Okay, so step 1 is, what is the unbalanced equation? Well, there it is, right there. So step 2 says identify all the oxidation states of all of the atoms. So when I go through assigning here, I have Cl2. Each of them pulls the electrons the same amount, so it has a 0 oxidation state. Solid aluminum also has a 0 oxidation state because it has its own electrons. This aluminum ion is a +3, the same as its charge, and chloride is also the same as its charge, -1. Then we look and see, okay, what's gaining electrons and what's losing electrons. We use tie lines, we call them, to recognize that. So the chloride goes from 0 to -1, which means there are 2 atoms that are gaining 1 electron. So that's a total of 2 electrons being gained. The aluminum, I'm going to write it up here, is going from aluminum 0 to aluminum 3+. That is a loss of 3 electrons. Okay, so if we have a gain of 2 and a loss of 3, that's not working out. We can't create or destroy electrons, and so we need to find out what is our lowest common multiple between 3 and 2, so that I can make these numbers of electrons being gained equal to the number of electrons being lost. Well, I know 3 electrons and 2 electrons, their lowest common multiple is 6. So if I multiply this by 3, I will get 6 electrons. When I do that, that means I'm going to put a 3 in front of here. That's each chloride is going to be gaining 1 electron. And so then I also need to put a 6 in front of here, because again, each chloride is going to be gaining 1 electron. And so I have 6 chlorides doing that. If I am going to be gaining 6 electrons, I need to lose 6 electrons. So here I need to multiply this by 2. So that is a loss of 6 electrons. If I put a 2 in front of there, that means I have 2 aluminums, each of them losing 3. And here's my 2 aluminum ions, each of them with the loss of 3. Then the last step is to balance by inspection to make sure all of the other elements are balanced. And in this case, there are only aluminum and chloride ions, or atoms, and so that is all balanced. And this reaction is now balanced according to the number of electrons being lost and gained. You'll see that it would not be the same if we had just balanced it normal with the number of elements. If I would have done that, we would have ended up something more like this, just putting a 2 in front of there, and it's balanced. That's not correct, because that would not mean the number of electrons being transferred would be the same. So this is why in a redox reaction we have to look at how many electrons are being lost and how many are being gained, so that we make sure that it's the same number being lost and gained.